I'm Alessandra, and I work with Eimur, and I promise I'm the last one of us. I am a trained biologist. I just finished my PhD last year with Howie, and I'm also part of a science communication platform. We share about fish research in Iceland. If you want to check us out, it's Ice Fish Research. Has nothing to do with the ice fish, the species. It's an unfortunate or fortunate coincidence, however. And now for the last couple of months, I've been working with Eimur, especially on circular economies and how we can valorize our waste or garbage, however you want to call it. I prefer to call it underutilized resources. It sounds a little better than, garbage. So yes, today we will talk about hot water bleeds in Northern Iceland. If you don't know what a hot water bleed is, that's fine. It is the intentional discharge of water to maintain network stability and temperatures, and particularly in rural areas. Now, this is important or necessary because in the rural areas of Iceland, houses can be far apart. And the companies are required or have made the commitment to deliver 50 degrees warm water to every single household if they are connected to the direct district lines. Now, that means that if you're far away, to ensure this, there needs to be a constant flow so that the water doesn't just sit in the pipes and cools down. Additionally, also, if the water just sits in the pipes, microbes can grow and flourish. So it also has a hygiene aspect to it all. So for that, also to have, so the main purpose is to keep the minimum levels of the temperatures, increase hygiene so that we can just drink from the tap water and we're not gonna fall mortally ill because we swallowed a little bit of the hot shower water. Yes. Now, the downside, of course, is that we are wasting a lot of energy because this water is currently just flowing out into the environment generally at distinct bleed sites. And of course, it also increases the operational costs because now we need to move a lot more hot water than we're actually utilizing. And this wasn't really an issue because we all know Iceland has a lot of geothermal hot water in certain areas. But even in those rich areas, we're starting to hit the limits. And so questions of greater efficiency, but also sustainability to upkeep the costs and to still be able to deliver to all the rural recipients because there has been a lot of movement towards city centers. So the rural areas are a bit under pressure also from an infrastructure point of view. So we got really lucky. We got data from Skagafjörður and from Eyjafjörður. So on the left side, yes, we have Skagafjörður, and on the right side, we have Eyjafjörður. On the y-axis, you have the volume of hot water lost per year in cubic meters. So we lose up to 30,000 cubic meters of hot water in some of these sites. So each on the x-axis, you just have the hot water bleed sites. So we know the names of the stations. And the color indicates the temperature. So the darker the blue, the colder the water. That being said, because we want to have 50 degrees in each household, the bleed is at the coolest 50 degrees warm. Now that gives us the opportunity to actually utilize the energy. Now here we have the same setup, but instead of volume, we now have energy in gigawatt hours per year on the y-axis. And what we see is that in Skagafjörður, we have a lot more volume lost. And that is because we are much more rural. I am living in Skagafjörður, that's why I say we. It's a much greater area, much more sparsely populated compared to Eyjafjörður. So Eyjafjörður can utilize the water a bit more efficiently and doesn't need so many bleeds or such large bleeds. And the temperature in Skagafjörður was actually generally lower compared to Eyjafjörður, but still the energy lost in Skagafjörður is much higher. So there's a lot of people can look at half full and say there's a lot of potential. No. There. So one of the first steps after kind of getting an overview was to actually put it on a map, because as we've learned today, maps are great. So I've worked in collaboration with one of our students on actually mapping our wastewater or our underutilized hot water. So you see, for each of these dots is one of the bleed sites, and the bigger the dot, the bigger the loss of energy we have. Now I've made this interactive, so you can click on the dot, you have the information of the site, you have the temperature, you have the volume lost, and also the energy lost. So this is really also for municipalities to get a good overview of where these bleeds are, how much is lost, but then also for investors or people that want to utilize these resources to know where they are. Because if you have a couple of bleed sites together in a convenient location, that makes a much better, greater case for building up a certain business compared to if a bleed is relatively small and remote. So this is really to show kind of, to identify opportunities in terms of geography. From Eyjafjörður, we also got more detailed data across the year. So here in the graph, you see on the x-axis from November 2024 until October 2025, the energy lost across the year. And I guess with no surprise, we have less energy lost during, we have more energy lost during the summer months, actually, because less hot water is used to heat houses. And this is mostly what we use it for, to heat our houses. So there's actually more bleeds in the summer, which is maybe not necessarily what you think of useful in terms of utilization. We might want to use it more in the winter, but there are ways to do this. So how can we use these resources? And these are just some examples. For example, land-based aquaculture, like Stolt Sea Farm, they're growing Senegalese sole in the south. Mushroom cultivation, algae and seaweed cultivation is already in trial. One could also imagine heating outdoor fields to actually prolong growing seasons or allow certain crops that currently are challenged with our climate to actually manage to grow. But as we've heard previously today as well, we could heat these manure lakes to actually make methane production more possible. Today, however, and of course the bathing lagoons are always a top seller, though our bleeds are relatively small and they're generally on private land. So those people don't necessarily want a bathing lagoon next to their barn. But nevertheless, there's always potential, of course. Today, however, I want to focus on snail farming, one of our most charismatic projects. People really love them. They are very adorable. Yes. So we've been very lucky to collaborate with Innis Escargot, which is the first Irish snail farm ever. So the owner, Peter, is a real pioneer in snail farming in Ireland for sure. And he has been very kind and has offered us a lot of expertise and insight. So why snails, you might ask? Well, they're actually, they don't want it super hot, also not super cold, so 18 to 21 degrees, which if you think we have 50 degrees temperature water that is just wasted, even if we have to transport it somewhere, we can still heat it up to that kind of level. They also really like it humid, which also takes care of a lot of other issues. Another advantage from a practical point of view is that they're actually very low starting costs for the farmers itself. They have good profit margins. It comes around really quickly. Peter estimates that in Iceland, the growing season could actually be compressed to 6 months, and that the costs of heating could be reduced by about up to 70% in Iceland compared to the mainland of Europe, because we have this geothermal hot water. It would also give farmers a way to utilize empty farm buildings and to have a solid side stream to their main farming activities. Additionally, snails not only are a great protein source, but they also have a relatively small environmental impact. And there are various applications. You can have them as food in restaurants, and they're a high value crop. So that's where the good profit margins come from. But the lower quality snails can also be incorporated in pet food. The mucus that the snails produce are used in cosmetic products. And the shells can then also be recycled and be used as fertilizer. So they can really be completely integrated into the economy. Now, we have had the great opportunity to have actual Icelandic farmers that are interested in starting snail farming or to get into snail farming, go to Ireland and visit Peter's snail farm. There we got hands-on experience so that they really got a realistic insight into what it means to have snails, how much effort it takes on a daily basis. And Peter is also committed to mentor future farmers, which means that we can get all the insight and the practical knowledge that comes with experience, because this would be a completely new area for Icelandic farmers. And if we do have some farmers, so we're currently in the state where we have farmers thinking about the feasibility for their families often, but also their collaborators. And we could have our first snail harvest in Iceland as early as 2027. So I wonder if you would also have a try. They're delicious. So I hope you've heard a lot about Iceland and the North, especially, and what we do at Eimur. If anything today in my presentation on any of my other colleagues has inspired you or made you curious, please reach out to us. We're always open for collaborations. We also love to have student projects. So if you want to send us your student or you are a student, please reach out. We're always very, very happy to have you. And with that, I thank you.